are multiplying two time domain quantities, which is technically wrong because it is not a multiplication, this is a convolution. So that's why for a dynamic object you cannot do this thing. So if you really, that is if you don't know the other technique, and that is if you have only this technique, then you have to do it in the frequency domain, I mean in the Laplace domain. There it is allowed. Okay.
So here we are considering it as a zero state response, right? X of zero.
Yes, but if you include the zero free response, including that also we can prove, because both of them are linear quantity. Since the system is linear, so that's why that is we always add. That is also one very important point, that is when we write the total response, this is the forced response part, and then what will be the free response? E to the power 80 x0. What is the reason? That is why we directly add. We can add, that is only because it is a linear system, right? Because otherwise we cannot do that. Linear system, you have two driving forces. One is the initial condition, another one is the external function. Individually they will be producing their responses, right? Whatever displacement or whatever may be, and we are adding without checking anything because of the linearity property. Okay? And then that is we need further discussion, but first you try. Then the second question, what do you mean by time invariance? Miti, any doubt?
So when you add this term, it becomes an affine.
No. Here, why the concept of affine is coming? There, it is because of the linearity property. We are not proving the linearity property, but we are exploiting the linearity property. You have the responses for two individual causes which you are adding. Say for you just go back to circuit theory. Suppose in a linear RLC circuit you have two sources. Then if you have to find out the current or voltage through or across any particular branch, then what would you do?
Shut down one and you find.
And why is that method correct? Because the circuit is linear, right? Here also the same thing. You have two driving factors, one is the initial condition, another one is the forcing function. You have individual responses and then you are adding. So before writing that you have to ensure the system to be LTI, otherwise you cannot do that. Okay? Then coming to the property, what is time invariant?
Change the input.
One by one.
In a very general sense, whenever you perform the experiment, it should not affect the output.